As stated in the video about the watering versus drying, a serious drawback with drying is that it's energy demanding. The water that is to be removed is evaporated, and for each kilogram of water we want to evaporate, we need to add evaporation enthalpy to the system. So how can we supply that energy? One option is to have direct contact with a hot surface, like when we use iron to dry a wet shirt. In many industrial applications, condensing steam is in turn used to heat this surface from the other side, for example when drying paper by letting the paper travel across steam-heated cylinders. If you dry something in the oven, you typically supply the energy indirectly through a hot surface, the oven walls. A variant of supplying the energy indirectly through a hot surface is to use infrared radiation, much like they do in kebab restaurants when they cook the meat by rotating it in front of an infrared heater. But infrared is not the only specific wavelength you can use to supply energy. Another way is to use microwave radiation. The focus in our course in separation processes, however, is to supply the energy using a hot gas, such as air or overheated steam. In our calculation exercises, we will focus on drying a surface wet material using hot air under adiabatic conditions. Under these conditions, and if the drying goods are heated to the wet temperature of the incoming air, the air inside the adiabatic dryer follows the adiabatic cooling line. For moist air, the adiabatic cooling lines are essentially the same as the wet temperature lines, as long as we have modest temperatures and air-water contents. Note, density of air varies with both temperature and humidity. Thus, you can't make mass balances in volume units and definitely not energy balance in temperature units. Instead, you need to use proper units. For mass balances, either kilogram or kilogram per second or some other time unit. For energy balance, either joule or joule per second, that is watts. In exam questions, I often specify one airflow in volume units and request that you calculate the volumetric flow or some other flow in volume units. As soon as you see any volumetric flow of a gas, directly convert it to a mass flow using the density for that specific flow. Because if you don't use correct units in your mass and energy balance, you are in essence breaking the fundamental rules of thermodynamics. And breaking the rules of thermodynamics will in turn be taken as a sign that you don't understand what you're doing, and thus you will unfortunately lose a lot of points on your exam.